Welcome everyone to Mr. Schultz's Integrated Math 1 class. Today we're going to discuss lesson 3-4, Intercepts of Graphs. When we have an intercept of a graph, we are basically going to be talking either about the x-intercept or the y-intercept. If it's the x-intercept, it's on the x-axis. I like to call this informally the ground. So if you have something and it's going to hit the ground, you want to know, where did it hit the ground? So in this graph right here, we can see that it hits the ground at 3 locations. Now, the next part, we have the y-intercept. What is the y-intercept? Well, the y-intercept is the wall. This is where it hits at a certain location, where x equals 0. This is the y-axis. The y-axis is when x is equal to 0. Now we can see that it hits right about here. Now, at any point, if the function is positive, that means it's above. So that would be, let's use the highlight, the markup, I guess, the highlight, freehand highlight. So that would be like anything above. Anything above would be positive. Now, anything below the x-axis would be negative. The function is positive when it's above the x-axis. The function is negative when it's below the x-axis. All right, let's go on. So, example 1. Intercepts of the graph of a linear function. So it says use the graph to estimate the x and y intercepts of the function and describe where the function is positive and negative. All right, well, the first thing I would do is I'd probably, circle, and it looks like it hits exactly at these points. So at 0, 1, 2, 3, 4, 5, 6. So the y-intercept would be at y equals 6. The x-intercept, looking at this, would be right about here, where it is x equals 1, 2, 3. There it is. Now, we understand that the function is positive when it's above. So at x equals 3, it hits. So when x is less than 3, it's positive. When x is more than 3, it's going below the x-axis. So this is negative. And I would say when x equals 3 that it's neither positive nor negative because it's 0. 0 is not positive or negative. It's 0. It's nothing. All right. Now, technically, if they're asking, we'd probably want to describe it. And we'd say the function is positive when x is greater than, or when x is less than 3. And the function is negative when x is greater than 3. All right, let's go on. Example 2. Intercepts of a graph of a nonlinear function. All right, so this looks like a quadratic, a parabolic shape. Well, it looks like that it has an x-intercept. We could say, the y-intercept. The y-intercept is going to be, we could say that y is around, it looks like it's around 12. We're doing an estimate. Now the x-intercept looks like it's going to be at x-intercept. There's a couple spots. It looks like at x equals -4 and x equals 3. And now I can go ahead and type in my result. I would say this function, now remember this is a function because it passes the vertical line test. For every input, there's only one output, and that's this. So although it's not a linear function, but that's okay. This function is positive Well, there's certain spots. It looks like it's positive when it's less than -4 and greater than 3 for the x. So let's throw this in. It's positive when x is less than -4 and when x is greater than 3. So now I have to explain when it's negative. All right, this function is negative when x is between -4 and 3. All right, there we go. Let's go on. All right. Example 3. Find intercepts from a graph. All right, sports. The graph shows the height of a ball for each second that it is airborne. Use the graph to estimate the x and y intercepts of the function, where the function is positive, negative, and interpret the meanings in the context of the situation. Well, it looks like there's only one y-intercept and that there is one x-intercept. So the y-intercept is y equals 4, and the x-intercept is x equals 9. So the height, all right, well, it looks like now we can say it's always positive because it doesn't dip below the x-axis. Now, why is this the case? Well, this is going to be the case because, unless we dig deep into the ground, I mean, it's not as if we're going to go below the ground. I mean, technically we would say sea level, but if it goes into a hole, technically the ground is below, but let's just type it out. All right. The ball starts at 0 seconds being thrown at a height of 4 feet. Well, that's probably at how tall the person he's throwing the ball. It goes up, and then it comes down. Now, if we wanted to be more specific, it goes up until about 3 seconds, and then it's going to come down. Next up, get out of there. Following that, the ball comes, you want to be specific. The ball comes down to the ground, the x-intercept, and touches it at 9 seconds, 0 feet up. Now, I would say it probably would bounce a couple times, so this isn't giving us all the information. All right, let's go on. Find the intercepts from a table. All right, I mean, I don't even have to read the scenario. When x is 0, y is 150. Okay, so the y-intercept is 150. The x-intercept is x equals 40. All right, well, Violet starts the semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount. All right, well, let's explain. We just have to explain the two intercepts. Okay, so get out of there. Violet starts her semester with $50 at 0 days. After 40 days, she has $0 left. These were the y-intercept and x-intercept. Okay, that's it. We don't have to do anything with that. Let's go on. All right. It says solve equations by graphing. So give me 1 second. So I don't really like how the problem sets up. I mean, if we were to solve these, we would divide by 3 on both sides and we get x equals 2. But like x equals 2 would be like 1, 2. Like it would hit right here. So there's nothing on this right here. Normally, if we're going to have a function, if we're going to graph it, we would have, well, let's break this down. X and Y are two variables. We'd have two number lines. We have the X and the Y. And if you look at this, there's only one variable. So I don't like how the examples start this up, but we can actually graph it and show it later, like if we had the Y. I mean, even looking at this, like if we add 3 both sides, we get x squared minus 4x plus 3 is equal to 0. I mean, once again, there's only one variable. So technically we wouldn't have this right here. Like we wouldn't have this because we don't have the y. They want us to pretend, hey, what if we pretend it's y? And like, all right, well, that doesn't really help us. I mean, technically we'd have like x minus 1. Like if we factor this, it would look like this. How do we factor it? Well, we'll get into that later. And so we get the zeros 1 and 3. So like that's where we get this right here, 1 and 3. But it's not how I would try to solve it. I would get this function and I'd be like, okay, y is equal to x squared minus 4x plus 3, and then I would plug and chug. I'd plug in some numbers, or I'd use a graphing calculator. I would put the information into Desmos and I would see, okay, where does it hit, and be able to explain it. This doesn't do that service or justice. All right, let's go on. Example 7. Graph the horizontal and vertical lines. Well, I mean, if you just understand horizontal and vertical lines, y equals 3, okay, which one's y? Well, the uppy downy, the wall is the y. The x is the ground. So when y equals 3, that's like right here. Like 1, 2, 3, right here, right here, right here, right here, right here. So everywhere along this line, y equals 3. So y equals 3. And then when x equals negative 4, we just go 1, 2, 3, 4 backwards. And it's like, all right, everything along this line right here, x equals negative 4. That's it. And that's it. So if you're struggling, what you can do is you can always go to desmos.com. Desmos.com. And you can plug it in, like y equals like x plus 3. And it will show you the graph. It's fine. Totally fine. Or it might say like f of x equals x plus 3. In either way, it will show you the answer. Well, show you the solutions by graphing. All right, guys. Thank you very much. I'll catch you guys in class. Bye.